Hi everyone, I am making this series of videos to make it easier for people to transition after learning SolidWorks to actually using it and making FTC robots. And I thought a nice introduction to this would be making a MANTIS robot, which is an introductory Tetrix robot that the Carnegie Mellon Robotics program actually designed and is used as one of the first beginning robots for teams to make. So if you see, you'll right down there in the YouTube comments, you'll see a link towards the building instructions of the MANTIS robot, and also a file that contains all these Tetrix parts that I've compiled over the years of actually using it for the FTC. And today what we're going to do is try to make this MANTIS robot on SolidWorks virtually. So let's just get into it. The first step is for you to make an assembly. Obviously, you would make a new assembly, and since the first step has 288 channel as its center, let's use that as our center as well. So now you'll see that this channel is fixed. It means that this channel will be used as the reference for the positions of all the other parts when you're going on to make this robot on SolidWorks. And you'll also see that there's an axle shaft that they're using. Let's go with default. And what we want to do is we want this axle shaft to be in this hole. So what you do is we click concentric. But the problem is it didn't flip the way we wanted it to. And although there are ways of changing it when you are mating products, another just simple way is using the right click, rotating a little bit to the side, and then using the concentric feature. Oh, oops, let's go back. And then using the concentric feature to put this part together. Something that you'll obviously see is you need to be able to get access to this hole if you actually want to make something physically. So what you'll have to do is you want this to point outside, which means you want these two holes to become concentric, so that this could be easily accessed by outside. So let's go press this circle and that circle, make them concentric, and you'll see that this is still not yet well defined because this and this side have to become a coincident in order for the axle holder to be perfectly fully defined in this setting. Now we're done with this, let's go on to the second step, which is actually just bolts. So in Tetrix, in SolidWorks, you actually don't have to worry about them. But identify that the bolts are on the places where there are eight holes around. That means that we can use that as a reference to where our next part would go in. Our next part's a 96 channel. Something that will make aligning much easier in this case is we start off by making these two planes coincident, and which means that we can look at this normal to this, and as we can see the view, this channel stops around over here, so we know exactly where it has to go. And then let's make these circles concentric. Now you can see that this part is fully defined as well. We have to add the other part of this MANTIS bot, so press Ctrl and drag, and you can easily copy the things that are already here. So now I've copied the axle collar and the channel. Let's start off by mating the axle collar and the channel once again. Concentric. Move that in, and we want that to go over there. So let's make this circle and that circle become concentric as well. Make this and that to become coincident. And as we did before, we want this part and that part to be a coincident as well. And there are two different things that we can actually do here right now. we can use these holes to define where this is, or we can actually use its relative position with this channel to define where this channel would have to go. For example, that part and that part would be parallel, or would be basically coincidence when you're actually making it in real life. So even if you do that, you can easily see that this part is very well defined. And now let's go on to adding the Omni wheels. Where are the wheels? Alright, the Omni wheels are here. I have an Omni wheel here, another one here. Let's look at the different parts that we need. We need an axle spacer, not a large one, a small one actually, and then also an axle bushing. And now we have both of them over here. Let's move them so that we can make them. Before doing other things, let's start off by finishing this assembly. You'll figure out that this part and this part are concentric and also coincidence. Let's move that down there. Right now, to make assembly, making it a lot easier, let's fix the wheel so that it's easier to use these. Remember that it seems that this one is supposed to go into the same axle as the two other things. So let's start off by making these two coincidents and making that plane and that plane coincident as well. Now we have this done. Another easy way to, let's get rid of that wheel for now. Since we need two of these, another kind of easy way for this, you make this into a sub-assembly. So you form a sub-assembly over there, you copy it, and then you just dissolve the sub-assemblies. So you do it one by one. Dissolve sub-assembly. Also that one. Dissolve sub-assembly. And you'll see that these two are basically now copies of each other. Let's make the wheels into floats so that we can move them around. You know that this and this have to be in the same axle, so let's make them concentric. And then also, since these two bushings would be touching each other, let's make them coincident as well. Now part of our Omni wheel assembly is done. What we need to do is we needed to basically go in here. So you can pick any circle, honestly speaking, but then let's say these are concentric, and we know that these white bushings are supposed to be touching each other. So let's go ahead and do that. Make that coincident to that. And also we need an axle to go in there to put them all together. So let's take a D shaft. In this D shaft, you'll see that it's not perfectly circular, but then if you use the circular part, you can still define things to be concentric. So I'll go ahead and do that. Since this will be at the edge of this, I want to make these coincidents, and then you'll see that now this is done. So we are done with step number 6. And you'll figure out that we actually didn't have to take the exact steps in this print because we're not actually building them for real. Now they want us to flip this apart, up and down like this. Yes, something like that. And we are supposed to put in standoff posts. That's a 1-inch standoff post. And you'll see that we need to put it at the second high circle over here. Like that. I clicked wrong. That circle part. With that circle part, concentric. Where did it go? It's down there. We want this. We want that and that to be coincidence. Now what you can use is you can actually copy with mates. You'll figure out that this concentric mate should become another concentric mate over here, and you'll figure out that that coincidence should be repeated here. And you have successfully done your first copy with mates. If you are doing repetitive things on SolidWorks, copying with mates is a very good shortcut to take. Now it's time to add motor controllers and servo controllers. Since I hope my computer can take it, let's set this as default. Hopefully my computer can take it. You'll see that the center circle is aligning with this circle over here. Let's make these concentric, and also that circle with this one. I guess not. So sometimes things like this happen. If you see, the size of the high technic servo controller might not be exactly the same as this one, might not exactly be the same as the one that you've designed, making this error to come up. However, as you can see, a small difference in sizes are usually not a problem. A shortcut we can take is we know that these two planes are supposed to be parallel to each other. So what you're going to do is we're going to make these two planes parallel. And now what you've done is you've fully defined this, which looks perfect outside, and also if you see, the holes are lined up correctly enough so that it's not going to pose problems when you're assembling things. The next parts actually deal with adding the NXT controller onto this. However, as you know, we're no longer using NXTs for the FTC, so I thought it would be fine to just ignore those for now. And now let's go on to step 14. At step 14, we are making things to add the motors to. Our team doesn't really use the motor holders that's over here right now. We use the new ones that cost the same but then are much more versatile. But then that's why I actually just want to go on and use these motors. What I've done already is, no, I did not do that actually. Okay, so sometimes in CAD parts that I have given you, not everything that they sell at Pitchco is actually on it. And what you can do is go on to another thing that I have attached. They have parts that end with the word .prt, which means they're for PTC Creo. Let's go on and search for Pitchco motor holders. And as you know, there are two different motor holders. I guess not. Is that not the correct name for it? Let's go motor mount. Yeah, motor mount, not holders. So as you know, there are two different motor mounts. This is the older motor mount, this is the newer one that actually costs the same, but there are many more different ways to use it. You'll see that the product ID is 39376. And it seems that PitchCo puts the number 7 at the front to identify them as Tetrix parts. So if you go look for 739376, 39376. Here. This is basically the Tetrix motor mount in PTC Creo form. So what you have to do is you have to open it, and let's go into the Dropbox. You have to open it and import it so that you can use it on this one. Two-piece motor mount. It will ask you if you want to convert it. Using features to import the parts is much better. So let's try this. I guess not. Actually, let's go on to import it just as bodies, because that's honestly all we need for now. Other parts, if it supports, it's better to use features, but then sometimes you just can't import it using that feature. So let's wait a little. So here, we honestly don't use this part that much, so let's get rid of these. And now what you want to do is you want to save it as another file in your CAD parts directory. Say order mount new. Now you have this. Let's go and use this as a new part for our robot. Motor mount. Motor mount new. We also need a motor. So let's get both of them in here together. We know that these are supposed to be concentric, make them concentric. To make assembly much easier, let's just fix this for now. Actually, this might be easier to fix. We want this and this to be connected to each other. Let's do that, and you can see that they are using a 96 channel. No, actually a longer one, a 160 channel over here to assemble this part. Let's see, this goes to that circle. And you also figure out that that goes to the other circle over here. But then sometimes it's a little difficult seeing where things really go, so you might actually want to move things closer so that you have a better idea of where which parts fit exactly. This time let's make that coincident to this one so that it's easier to see where the parts fit. I guess the first circle was wrong. This doesn't belong here, it belongs over there. If you see, that circle should go there, so let's make these two concentric as well as these two. Yes, perfect. And what I'm actually going to do is I'm going to make this part first and then just flip it around. Although this time that might not work because the parts are not exactly the parts are mirror images of each other, and that means that we can't just do what we did last time and form them as sub-assemblies and dissolving them later on. This time we'll have to make extensive use of copying with mates. But then, since it's better to finish one part first, let's finish one side first and then start copying with mates. We will need a standoff post and also a motor shaft holder. Let's move these closer to here. Let's start off by defining where the motor shaft holder goes. Since we have a lot of mates to do, let's actually just go into this mate menu this time to start defining mates. What this mate menu sometimes does is it does all the mates first and then shows you what's happening. So it's actually one of the faster ways of doing mates when you have a lot of mates to define. That's another one, that wants to touch that place, so let's do that. Now the mates are done. And as you can see over here, it seems that when we were mating these, this actually went in there where it's not really accessible to us anymore, so let's just delete that. Give this an approximate position. Insert the wheel. You know that this part of the wheel goes in there, and also that this touches is coincident with that. So we have one side of our assembly done, and I just want to go ahead and plug this up to the side of the base that we've been making until now. Drag it. And you'll see that this is the correct position. And once again, to make positioning a little easier, let's start off by making these two coincident to each other. Sometimes it's just easier to use your keyboard when you're placing things. We can see that this is supposed to go onto that part, and this seems to be the right angle. Okay, so now that we defined these to be coincidence, let's go ahead and find where the circles are supposed to be in relation to each other. We want to make that and this circle concentric. Yes, like this. And now what we have left to do is we want to make the same thing that happened over here as well. So before we copy with mates, let's just start off by defining where this has to go. This time let's define this channel's position in relation to where this is supposed to be with. So we know that that and this is supposed to be coincident as well. We know that these are supposed to be in a coincidence relationship, and now we know that this is fully, now that we know that this is fully defined. And now let's go on to copy this with mates. Copy with mates. You know that the circle's there and the plane is there, and this is well defined now. Let's copy the entire assembly. For the assembly, don't click on, when you want to actually copy an assembly, you can't actually use this because you just copied a part. If you want to copy the entire assembly, you have to go to this file manager to drag the entire file into the thing altogether. Let's reproduce the mates. This time let's actually try using the mate feature in the assembly. We want these to become mates. You know that circle will be a mate with that, and also that will be a mate with that. Perfect. We want to copy the motor, concentric, as we know, like that, so coincident over here. Let's get the wheel and the axle holder down there. Let's roll it over so that the axle holder, I mean the motor holder, is in the correct direction. The same thing happened again over here. So this time let's move this farther out and then make these become concentric, but hopefully the same thing would not happen again. Give this a random position because that's actually what we do when we make this in real life. And then define the wheel. Now this part of the assembly is nearly finished. Just to make this two wheels, just to make these two wheels align as a nice finishing touch, let's just make these two parts coincidence. Actually, not coincidence, just parallels. So that these two kind of move around together. Now that we're done with that, let's add the claw. Similarly with how we did everything else, we're going to make the claw in a different part. We would first start off with the short channel, as you can see in the building manual. Use an axle spacer. Also get a single servo bracket and a servo as well. Actually, let's first start off with making the servo. We want to fix this initially in order to define where the servo goes. This seems to be around the right place where the servo is supposed to go. To make it easier for us, let's make this parallel and make this parallel as well. Now all we need to do is just drag it into the right position for us to correctly define the position of the servo. Sometimes parts like the servo are not, the holes and other things in parts like the servo are not exactly the same as the part that we want to make. So using parallel features and other features to define where they go is actually easier for our purposes, because we want to use SolidWorks for finding out where parts should relatively go in positions related to each other, not to get a perfectly exact idea of how which parts fit which parts with the accuracy of 0.1 millimeters. So let's put that down, and you'll see that the axle spacer goes over here. We know that this is supposed to be a coincident with this. We can use the circles to define where they are, but then since the circles are down anyways, let's just use the parallel mating to define where these parts go. Now we have to use a servo horn and also a servo, and also a 32mm gear, a 32 tooth gear to define where these things go. The horn obviously goes over here. Same problem once again. Let's roll that over a little so that it won't happen again. We know that the horn hits that part when it's assembled, and let's just connect the gear. Coincident, and this time concentric as well, although this is not really required when you just want to see how things work out. Now that this part is done, let's make this floating again, and then let's go ahead and add this to our assembly over here. We'll figure out that this is the right place for it to go. Let's start off by defining these coincident over here. And also we know that since this is a 90-degree angle, that and this would be coincident as well. And as a finishing touch, let's make these two big holes align. Now we are very close to finishing. We are very close to finishing the first Tetrix assembly in SolidWorks. To make the claw part, we'll need the short channel and a bracket, and also one of the servo pivot brackets as well. Let's start off by fixing this so that it's easier for us to make the assembly. And then we can do that again over here. This time we might actually just, because sometimes circles are kind of hard to play with. We may decide to make our mate like this. And actually, we'll figure out, you can see that the thing that I did is wrong. This is not supposed to go down in a right angle like that. It's supposed to be the other way around. Something that's good when we define relative positions of flat parts with each other not using circles is, if you change one thing, other things can easily change as well. So let's start off by getting rid of that concentric mate, and also getting rid of that, and then just rolling it up like that. We can use these two to be in relative relation over here. It seems that a part that we have may be wrongly defined. Things like this sometimes happen. Let's go in and see what's happening. We know that the distance between this and this part is supposed to be 16. That and that, we'll see, is driving. Let's make that 16. We'll soon see that these are the problems. Our part is fixed. So let's go ahead and try to fix our problems once again. Now they are mating. As we did before, let's just plug that in over here. Our claw is done, and we have to flip this around at the top. Sometimes for unknown reasons, parts dimensions sometimes just change, and when they do, we just have to go into the part and figure out what's actually wrong. Now that our claw is done, we have some other parts that we need to make it finished. We need 2 axle shafts and 1 gear, so what we're just going to do is we drag them in again. Our gear somehow went there for some reason. Make these concentric. We know we want this to be coincident with that. This should go in here as well. Make them there. Since this is still rotating, you know, we want this and this to be in that relationship. And let's use copy with mates. That circle is there, that coincidence is there, and that circle is there as well. So now we have copied this one. Our claw is finished, as you can see. Let's go and add this to our servo at the back. We know that that small channel is fixed, so let's make that floating. And just to make things easier, let's start off by defining the concentric relations with this, like that. Phew. And you'll see they fit. As we have to do, let's add in the D shaft, the bushings, and the axle spacer. You know, the bushing is supposed to go into this. So let's make these concentric. Push this in. And something that we might want to do is, we know that this is around the similar length, and we also know that these are not going to end up aligning perfectly. So just to make things better, let's just define a random distance between these two planes, so that we can usually, so that the axle just doesn't pop up and down. You know, this is supposed to go there. That should go in there. But you also figure out that it's actually kind of becoming really tedious to use this tight amount of space to define where things go. And that's why you would not have defined this perfectly before, because it's easier to move this in and out to give you better positions to put in the mates. As you did that, let's go and copy this. This is far out, making it really easy to get access to the edges. And let's put that in right there, like this. And also add in that finishing touch. Now we're actually done with the MANTIS spot. You'll see that this moves up and down. But since this is not moving around with the motor, let's just, for the sake of making it look better, let's give them this concentric relationship. You'll see that this part moves with the claw. And this MANTIS spot looks very similar to the one that is on the making guide that we see over there. So for finishing touches, let's go and add the servo controller. Flip it around. We have lots of mates to make, so let's use that feature for now. That circle goes with that circle. No. Remember how sometimes these things are not perfectly defined. So sometimes you have to just use other relations instead of concentric to define where things go. Something that you know for sure is that should touch this plane, and that and that this plane and that plane should be also like that. Now we have the servo controller in there. Let's go ahead and add the battery. Let's get one of the angles that we use to shut that in. First the battery and then an angle. wrong click, wrong click. Let me go ahead and fix this up. Goes in like this. So the battery is the last thing that we have to attach to this document in order to finish our first assembly. No, this goes and is coincident with that. Oh, actually this is in the wrong place. So when we figure out that one of the mates is wrong later on, all we can do is we go here to see which mate we are supposed to change. So yes, we are supposed to let's go there and we'll figure out that this is a wrong mate. So we'll move that up there. It's going to it's going to cause problems. But then remember, the thing it's going to cause problem with is what is the one that's over here. Oh, that concentric, if it is changed to this concentric, hopefully all the problems with the mate should be solved. And you see that they are. And once we do that, we can figure out, we can just give this battery an approximate position. Say, give it a distance in between these two. That's the distance is currently 37, so if you make that 15, it fits okay. And we put that like that over there. And we see that the assembly is mostly done. So you can basically see that the picture that you see at the front is very similar to the one that we have right now, except the wiring and the NXT, which are usually just tedious work and do not really add to the modeling value when you're building things on SolidWorks, because even when you do actual wiring, you're not going to do exactly what you did over there. And this concludes the first assembly, and actually I think will be the last assembly that we make together, only because usually making assemblies become much easier as you start devoting more and more time into it. And in this video, I think I have shown you mostly all the techniques that you need for assembling Tetrix parts, and I surely hope that you guys go on to practice. Say, like, if you have any previous rollouts that you made for previous competitions, I highly suggest that you go ahead and assemble those so that you have a digital copy of the robot that you guys made. And on the next video, I am hoping to cover how to answer the question, should I buy this part, if you're about to buy the part online on, say, Webmaster or AndyMark, and there's a CAD file that you can download and check if it works with your order or not. So thank you for watching this first video, and I hope to see you guys again soon.